Hello, this is sort of a cloudy Sunday day, so I'm coming in here because today I'm going to be talking about powering up the Fortress. Since the weather's still not good and we're still in winter time, I do have some extra time, so I might as well get some stuff prepared for the Fortress before I'm able to get up there and start working again. One of the big things is getting power to it, and I've used so many different types of wind turbines before. Ones by Southern Wind Power, and then there was some other off brands, and I sort of come down to the point where I'm just simply using cheaper Delco based alternators as the generator. And there's some people that do some modifications, add permanent magnets into it, so they work really well. They produce quite a bit of power. So the one thing nice about this is when I'm starting to look at all this, I get a lot of pretty gnarly weather up on top of the mountain. So one very important thing is things need to be able to be reliable, last a long time without me having to fiddle with it, and very easy to be repaired. When you're thinking about powering up whatever you have, a Fortress, a house, a cabin, or whatever, there's a lot of factors: cost, availability, repairability, how long mean time between failures, which is how long it will last before you have to work on it. And there's pros and cons on every route. I prefer to go the route which is the simplest, and where I can do all the repairs myself. Most of the parts and materials needed to repair it are close to home, and the cost is not so high, and it is very easy to remove and repair. So simplicity is always the best. Cost is a factor, but also on the sustainability. So for the first thing, here is basically, I would say, an aftermarket rebuild of the turbine blades that were made. I remember years that had an Air 403 from Southern Wind Power, which I used. That was the first one. They were pretty expensive. It seemed to me they were like one of the first to use these type of blades. I do not have a picture of my 403 here. It's up at the top. It worked fairly well, but the pivot bearing ended up failing on it, so it would need to have some modifications done to it. Also my PMA, which is the Delco version alternator that was modified to have permanent magnets. I've got a new one up there and a couple old ones. One of the issues I always had on them was them burning up the windings. One of the big issues I found on that was they put the voltage regulator, which is basically 6 diodes in a pack inside the alternator with the permanent magnets. Well, the permanent magnets on the high speeds can produce a lot of power, and I didn't use any sort of like limiting resistors or anything for it, so I got some windings that burned up. But there's a local alternator generator repair place. I was going down there, 18 bucks, I got me another winding. And they would sell me windings either for 12 volts, 24 volts, or whatever. But I also looked at them. They're not that difficult. You could rewire them yourself for even a slightly different voltage, maybe something between 12 and 24. Because sometimes you want a little more higher voltage if you're going to be traveling a long distance with your wires. And the other issue, so what I did is I noticed, I did some tests, that most of the heat was coming from the contacts where the main windings inside the alternator were being connected to the diode pack. So one of the ways I found to remove that whole issue, because diodes, they rectify it from your AC to DC, basically, since the alternator is a 3-phase alternator and it's being rectified to whatever DC voltage you have, there's heat involved in that. And so that would heat up, plus your windings, and then you got that solder connection right there. Always was a weak point. So I decided to just remove the diode pack altogether. In fact, I've decided not to have any diode packs on the alternators to begin with. So they're basically now back to a generator. And so also nicer about that is I decided to rectify the voltage back at the battery bank or the controller that is charging the batteries. So therefore, when the generator is actually the alternator, which is now a generator because it's not rectifying, it will send out pulses, 3-phase. So I bring 3 wires from that. And it's good to put a 4th wire, which is simply a ground to protection for static charges, lightning building, whatever. And so it will protect and isolate the 3 wires for your 3-phase from your now generator. And you can run those 3 wires all the way back and then rectify it back at the battery bank. More efficient that way because you got a little higher voltage in the wires. And it just seems to be a very nice way of measuring how fast the windmill is turning at the same time. Because since it's creating a sine wave on the 3-phase, back at the battery bank, you can measure the time between pulses. And after checking out to see how your windmill operates, you can calculate how fast it is turning, what's its rotation speed. And if you do some more experimentation with the wind pressure and whatever, you can calculate approximately the wind speed, which actually is very handy because you could say that, the windmill's turning very, very fast at this point. We might have an issue that we might need to just shut it down or something. To actually stop it from turning, people have like a lot of different methods. I'm going to go with a little more expensive way. Basically, these will be like mounted inside buildings, which then I'll have shutters that can close to shut it down. One other thing that would be nice would be a way to measure vibrations on the generator itself. So in case something breaks or gets off balance, you can then close the shutter and not, completely destroy the bearings or the alternator itself. You can like detect if there's a lot of shock on the generator vibration. You say, uh-oh, something's going wrong. Let's shut it down before we have a catastrophic failure. So I've got a bunch of different ideas on how to do various of these projects. So I've got a little bit of time here in the winter to prepare some of this stuff for installation as soon as the snow melts. So I don't have a lot of time to do a lot of modifications and stuff, but so I'm going to basically take and slightly redesign some things that have already been done. So, and the first will be these turbine blades. The turbine blades. Since I don't have the PMA here or any of the other stuff, I brought this down off the mountain. I want to replicate these and also design them to be used in bi-directional mode. All these that I've purchased this off of eBay. I do not remember exactly the length of this. This was one that was designed that was supposed to be able to use on the Air 403. It's 28 inches. This one might be a little longer. I think for the Air 403 they were like 24. And I don't necessarily trust the bearing putting more weight on it. But since I'm not really going to use that, I'm going to be just using my own designs. This is a good starting point. The issue, I can't use these really directly. I could, but it will work better one way than the other because these blades have a pitch to them, like on an airplane wing. I'm thinking that the reason that they put that pitch on it is the way you mount it on the windmill, when it spins, I guess if the wind is coming this way, it tends at the end to bend this blade. So I'm thinking they put the pitch on it right here where it comes and hits. That pitch causes lift. So instead of having your blade bend too much, it lifts it up. I'm only guessing on this. I just looked at the blade. I could tell from the end, it is pitched like the wing of an airplane. Then there's a twist to it, and we also got a non-linear curve going out. Because as it's spinning around, this part is spinning slower than the outer part of the blade. And so in order to get this sort of the unit to, I guess, distribute the force, you have more surface area down here close to the generator and less at the tip. Now what I plan on doing is I want to be able to make blades, replacement blades, myself. This is a fiber composite blade, and like I said, it has a curve to it, like on a plane. So it's designed to be used only one direction. And mine are going to be bi-directional. See, I'm not going to have my windmills rotating to the direction of the wind. I'm going to lose some efficiency because it won't necessarily be lined up with the wind always, because these are going to be mounted in the wall on the very top of the fortress. And the air will be passing either direction. And some of them might actually be 90 degrees to the air, so they won't operate at all. But because I'll be making these fairly cheap and last a long time, instead of going for a couple expensive, high maintenance units, I'm just going to go for a bunch of cheaper, low maintenance, less efficient generating systems for everything to operate. So one is I'm going to use the basic two-dimensional shape on this, which I'm going to replicate in SolidWorks. And on my screen there, I have a piece that I was working on the rear winch of the Het for Sparks Motors, but I will be bringing up a new page here. So I'm looking at making this out of flat plate, either steel or aluminum. I haven't yet figured out exactly which way I'm going to go. But my first one's going to be made out of steel because I'm going to use it probably as a bending template, because I have to fabricate this curved piece flat initially. And then I will have to bend a twist into it, which is very pronounced here at the base and then becomes less pronounced as we go out. Plus, I am going to make it so that it is the same on both sides and both faces, so that it will operate with the same efficiency either way. So let me get to starting to do the measurements on that. Okay, I've decided to use this 28 version blade. You can I purchased a couple different lengths on eBay. This seems to be like a perfect sort of length. It's not too long, not too small. And notice that they have this first curve here. And after looking at it for a while, I'm pretty much guessing that is basically a circle with a radius of 3 inches. And that's going to be fairly easy to do. But then I'm going to then take a whole bunch of measurements from each point here. Get the tape measure to sit. There we go. So, and then I'll make a whole bunch of measurements. Then I'm going to cut them in half and then do 1/2 of the blade. SolidWorks has a spline function which allows the making of a curve with enough points. So the more measurements I take of this, the more correct my curve will be. unless I make mistakes in measurements. So I have to sort of, when I put it in SolidWorks and use their spline function, I have to look, because if I have a number that looks a little weird, it'll cause the spline function to sort of curve in the wrong direction. So let's see what I've got. We'll start up and create a new part and then start working on making a steel blade, which maybe later on I will make them out of aluminum. But I'm going to just make a steel one that I can bend and then maybe make a template, so then what other blades that I cut out of the machine, the plasma cutter we got, I can then maybe heat them and cause them to warp exactly to the shape I want. So let's get on that. I've gone along and I've put marks, since I'm using this hole right here as my reference for everything, going 1 inch. So at each of these points, I'm going to measure this distance across right here, divide it by 2, and then make one side, and then in SolidWorks I'll just mirror it. So I already have my base modeling here. I got my first hole, second hole, the hole for the piece, and that it's not separated as what is the main body or not, but what I will do, I put some construction lines in to help me just sort of get an idea on how everything's going to work. Since I'm not like super expert on this, this is just the way that I've figured that works the easiest for me. But I knew right here, this distance here is the max between on the blade. So I know my curve is going to start at the point right there at the intersection. And there's some weird dimensions, because the distance between the two mounting holes measures, when I measure it, seems to be somewhere between 7/8 and 15/16. But I just decided to go with 7/8, because trying to go into a 30-second sort of thing, I don't think that was the case. I just think probably whoever did it, they just the holes may not be 100% right where it's supposed to be. But the mount off, the size of the holes are 3/4 inch holes. I made them just slightly larger, 0.3. When I put it in the plasma cutter, the holes will be slightly smaller than my measurements. So what I need to do now is I'll start my spline here, and that spline will end up going to, oh, whoop, there it is, right over here. That's the end of my the blade. I might not copy it exactly the same length, the more that I'm thinking about it. If it seems like I'm a 1/4 inch left, so it might be just end up a 1/4 inch shorter, because it looks like it's about 28 inches long, but maybe a little shorter than 28, but I think they just call them 28 inches long. All right, well, I'm gonna start taking my measurements from, I just marked down here, and I'll write them all down in a list. Well, sort of changed how I was going to do this a little bit. I redid my points, made a linear pattern. So now I'm going to put my spline in without the measurements. I'm just sort of like eyeballing it. It seems like I'm already off a little bit on my eyeballing, but whatever. So I'm just going to continue putting in my lines right here. Oh, my next spline is over here. Just keep on going. Sort of. or a little bit down. Well, it's a little rough. Now I'll have to put the dimensions to each of these points in. So, sort of got it right there. Sort of hard. It wants to, when I put the points, it wants to sort of line up with my previous points across the x-axis, which actually is nice when doing a lot of work, but on the spline, it makes it a little difficult because it suddenly jumps one to another. I can zoom in to try to do it, but then I can't see very far how far I'm going. So now I just got to start taking my measurements and getting my points in the proper position. Well, I turned into a slight problem. My little calipers here, the battery has died on it, and so it's useless, which I really needed to make more precise measurements. Now I'm stuck with using this. So it's taken me a lot longer with this, and I'm slowly working my points. I've got to get the points in here. So I'm basically going to try to get it with this. If it looks good enough, I'll stay with this. If not, I'll have to wait and get a battery. Well, things like that happen. So, see, it's a lot of little points. It takes a lot of little calculations because I'm just using these fractions here, and then I have to do a lot of calculations and then estimate between the lines. So, all right, I still got about 10 to do. After a lot of work, I finally got all the measurements in. Really wish I would have had my little calipers to work, but they didn't work. Notice that part of their blade wasn't an exact circle. I could tell by that by using the SolidWorks, and it was showing that it didn't quite reach. So I had to change my radius from 6 to 7 inches. That looks like it does it pretty good. So I've saved this at this point, and I am going to go through now and make a complete part. I'm not really 100% satisfied with this. I want to like check some of these distances. I might end up rechanging this center area right here because I want to make it so that it'll match up specifically to a plate. Right now this would match up fairly nicely to a 7-inch diameter plate. It's got enough spaces, but I'm thinking there's not enough. If I have to go to 8 inches, I might want to re-change how my blade is actually formed. So I am going to do this because number one, I'm going to have an example and do some experimentation with it. So I've got basically what I need. I will now finish this in SolidWorks, and then we'll cut one out and see how things bend and how some things work. That will show me more about it, but I may have to change part of the blade in this area right here. So that's all what you get when you do a little bit of R&D on this stuff, that you may have to come back and do a couple tries and tries again. But my spline is pretty close. It's not perfect because of the measurements, but let's try this thing out. I think it's close enough. All right, I already exported to a DXF file on the drive, and we're gonna cut it out and see what we got. Well, I found a piece of scrap. I think I can cut this thing right into this area right here. This will be good enough to do it. And I gotta move the machine back. This plate's sort of in my way, so I'm gonna push this plate back a little bit and do it. Oh, I gotta add my little right in there. All right, let me get the plate set up and then we'll get back to the plasma cutter. The plate was a bit heavy, so I just moved down to cut in this area here. I set my old blade on there so I know, because this is just a piece of scrap, it's sort of hard to line everything up to know, to tell the machine that I know what I'm going to do, especially since I give it a plate. So I've pretty much just got it set up as close as I can, and then this will be my 0 point. For some reason the laser is being really wide there, but I'll take this off. And I have already brought this in here, and I'm pretty close. I need to set my 0 point. Go up. Process, plasma, and thinking I'm like 3/16. Oh, where is it? It's over here. Was that 3/16? It's probably around 10 gauge. 10 gauge. I guess 10 gauge will be good. We got 50 amps. So I will select this one, apply it. I think I'm about ready. I'll slow it down a little bit. That's there. And close it. Now let's see what happens. Program start. Well, it looks like we did good, but I forgot to change how my lead in on the cut on my holes were, so the holes won't look so good. Forgot about that. But I managed to cut it out of that scrap piece, so and it's a test piece, so I think we'll be good. Well, yeah, I put it up. It's a little different than right here, and I knew that was going to be the case because when I originally put it together, I was thinking we were having 6 inches, but for this radius, but this is not actually cut to a radius of a circle. It's an arc instead. So I knew I was going to have that of an issue, but it didn't really bother me at the moment. So, now let's see. I might end up changing that in the future, but we got sort of what I want there. So we will yeah, now looking at more here, I might end up doing this with not a circle but an arc instead for the next one. Yeah, that's definitely not a circle, it's an arc. Plate. I'm almost thinking I'd like to maybe extend this in farther. I'm going to need to get one of the hubs for this in order to check that for certain. Let's like grind this down and see what we get. Now looking at this, I can see sort of my twist in this. So looks to me like there's a very small twist down there. So it'd probably be easier. Let's see what we can do here. Well, I'm gonna work it until I finally get it as close as I can to the original. This is gonna be interesting. I'm just gonna keep pounding on it, flip it over, do the other side, and then make sure that at the far end we'll have just a slight amount of bend to it. So just gonna take a little bit of pounding with a hammer, a little bit more, and we'll see what we get. Now this vise seems to be just perfect for holding in my work. You know, like set up. Got a bit of my bend in there already. I have to make a bend in this area right here because I've gotten this mostly. But use a big crescent wrench to help me here. Well, I've got it done and bent. Tried to create a change in the pitch down the axis the best I could. Didn't really take too much time. I think probably about 10 minutes. This vise happens to be just perfect for this. So, be nice to make 2 more of these and then try them out. But you notice I don't have an edge on it. I want to get all the bending and everything all done, and then I'll take the grinder and make an edge on it. But it'll always have to be done by hand. I don't have anything else to use for that, sharpen that edge. But so I think what I'm going to do now is I'm going to put an edge on it and call this good. I'll look for getting some additional pieces of metal made later. But looking at where it bolts in right in here, might be worthwhile I design a piece that comes in to strengthen this right in here. So that's a possibility of doing on the next upgrade on this. So, well, I'm gonna go and grab the grinder and put an edge on it. I've got an edge put on it, and it's all together. Now basically what I'm gonna need to do is make 2 more. So I usually design them to only have 3 blades per turbine, and I'm gonna have to grab a hub and then probably redesign and make my own hub to fit this. I'll probably make a hub designed to grab the blade with a plate, a pre-made plate that just bolts over this here to strengthen this area right here. But keeping the holes the same, this should allow it to bolt into all the standard hubs that everybody has out there. So, looks like I'm gonna have to go up and grab the PMA. We got a new one that I haven't converted yet to a generator. Probably try that one out. I don't know where the one is that I used before. It might have been in the shop that burned. I'm not sure. I will have to look for it. If it's not there, I'll just have to use a new one and modify it. So I am going to clean up here, and then I'll let you know what's going on. Well, got them here. Now there will be one thing that'll be on my concern as far as this steel blade is balance. Heavier the blades, the more important is the balancing. These graphite blades are a bit lighter. Whether or not I want to do this with aluminum and make it thicker is a possibility. I could make this out of thicker aluminum and cut it out. Now, the whole point of this process is to be able to make something that uses some high-tech knowledge about turbines, but be able to do it old school, that you can build them yourself. A lot of this stuff is good. Like, you can't necessarily rely on having society in a nice, calm manner. There might be times when things are very scarce or natural disasters where you have to build them. Yet I'm here on SolidWorks doing it. However, doesn't need SolidWorks to do this. And I could have traced this thing out on just a sheet of metal and then cut it out with a torch, a hand torch if I had to. It's just I had the tools to do it a little bit easier and a little bit faster. So the next thing I'm gonna have to do now is I'm gonna go and grab some parts like PMA and a hub, and I will see how everything fits up. If it fits up, I'll use this this model here. If it doesn't, I will modify this a little bit because I can see a few things here where there's weak points, and but like I said, if I make a standard bracket that goes on the front and back of this that comes in forward to hold it, that would actually probably solve probably my strength problems. But I want to get this figure this out as a radius, even though originally they don't do that, or if they did, they were copying it and just ended up with arcs instead of a good clean circle, because I want my PMA set up to just fit up in nice up to it just nicely. I like everything to fit up smoothly. So, well, I hope this project is going to be ongoing. This is going to be the first, probably many on the wind turbine. If you've got any ideas, you can always leave it down in the comments. I'll try to put on one of the comments a pinned comment from me, because I get so many comments I can't quite read through everything. I tend to only be able to read a small percentage. But just a little bit more fun with designing stuff for the Fortress. So appreciate all of my Patreon supporters and everybody that watches this and subscribes. It really helps. I was hoping to get to 100K by this time, but I'm still sort of stuck 93, 94K, mostly because with the the Fortress process on hold, just working on the forklift is sort of exciting, but not so much. Got more things fixed on it, but I will be posting on that too as more things come along. So I wish to thanks everyone. Keep working on your own projects. If you've got good ideas, hopefully maybe something that I did gave you a good idea. And keep building so you can build your own home as your castle or your fortress. And take care. God bless.